Hello, I'm Mr. Kissinger, and this is 5th grade math, Module 1, Lesson 12. Today we are going to be multiplying decimal fractions by single-digit whole numbers, including using estimation to confirm the placement of the decimal point. So we're going to use our estimation skills, our rounding skills, to try to double check to make sure that we're right in where we're putting our decimal point after we're done multiplying. So we're going to start by practicing a little bit of estimation. So it says, choose the reasonable product for each expression. Explain your reasoning in the spaces below using words, pictures, or numbers. So we have 2.5 times 4. So 2.5 we can round to, we can round it to 2 or we can round it to 3. Because it ends in 5, let's round it up. We'll make that a 3. And then we don't need to round 4 because we can do 3 times 4. 3 times 4 equals 12. Now, we need to figure out which one of these options is closest to 12. 0.1 or 1/10, 1, 10, or 100. Well, 10 is pretty close to 12. So we know that 10 times, or 2.5 times 4 is probably 10, but let's go 2.5 times 4 and we can do 20. 2 times 4 is 8 plus 2 is 10, and then our decimal point, and that is 10. So we would know if we didn't put this decimal point in and we got 100. Okay, 100 is not very close to 12, so we know that our decimal point should go here. All right, let's move on. 3.14 times 7. So do we think 3.14 times 7 is 2,198, 219.8, 21.98, or 2.198? So 3.14 is really close to 3 times 7 equals 21. Which of those is close to 21? Well, 21.98 is pretty close to 21. Letter C, 8 times 6.022, or 6 and 22 thousandths. So that is really close to 6. We'll do 8 times 6, which is 48. So our number should be pretty close to 48. 48.176. Our decimal point goes right there. Now, letter D, we have 9 times 5.48. 5.48 is pretty close to 5. And then 9 times 5 equals 45. 45 is not that close to 493.2. It's pretty close to 49.32. It's not close to 4.932, and it's definitely not close to 0.4932. So that's how we figure out where to put our decimal point. And then let's try a word problem. We'll see if we can use this skill to try to find out where our decimal point goes, or at least to double check to make sure that we're putting our decimal point in the right place. So it says Pedro is building a spice rack with 4 shelves that are each 0.55 meters long. At the hardware store, Pedro finds that he can only buy shelving in whole meter lengths. Exactly how many meters of shelving does Pedro need? Since he can only buy whole number lengths, how many meters of shelving should he buy? Justify your thinking. So if he wants to build a spice rack and he needs 4 shelves, we'll circle that because it's a number, 4 shelves, and they're each 0.55 meters long. He finds he can only buy the shelving in whole meter or 1 meter lengths. Exactly how many meters of shelving does Pedro need? And then, since he can only buy whole number lengths, how many meters of shelving should he buy? So we have a two-part question here. So what we can do to figure out how much shelving Pedro needs altogether is we can multiply 4 shelves by the length of each shelf, which is 0.55 meters. So we're going to end up with 4 times 0.55. And what we'll do is, instead of looking at this as 0.55 with a decimal place, we can also look at that as 55 hundredths. So if we did our standard algorithm, what we'll do is we'll do 55 hundredths times 4. And then we can multiply just like their regular numbers without whole numbers without a place without a decimal point. So 5 times 4 is 20. 5 times 4 is 20. Plus 2 is 22. And we have 220 hundredths. And if we make ourselves a place value chart here, and we look at 220 hundredths, we need a ones place, tenths, and hundredths. And we have 220 hundredths. We know that each 10 hundredths is a tenth. So we have 0 in our hundredths place right here. We have 2 in our tenths place right here. And we have 2 in our ones place here. Our decimal point is right here between our ones and our tenths. So we end up with our decimal point here, 2.20. Or 2 and 2/10. Because we have a 0 in our hundredths, we can take that right off, and it could just be 2.2 as well. And then we're not done yet. So we had one part of our problem. We have one part of our problem solved now. We need 2.2 meters altogether. But since he can only buy in whole number lengths, how many meters should Pedro buy? Now, if you bought 1 meter, that wouldn't be enough because we need 2.2. If we buy 2 meters, will we have enough? Is 2 more than 2.2? No, it's not. We're still going to need more. We can't buy 2.2 exactly because we can only buy in whole number lengths. So we'll need to buy 3 meters altogether. And 2.2 meters is how many meters he needs exactly. So this is the first question here, and then this is the second question. All right, so I think that's all we have time for today. Thank you guys so much for listening for our lesson 12, module 1 lesson, and we look forward to seeing you guys next time. Have a great day.